Now in this video we are going to talk about the vector product or the cross product Now A cross B gives AB sine theta into n cap. Now this n cap means the unit vector normal to the direction of A cross B. Now what is A cross B? Now suppose in a single plane, two vectors A and B lies and the angle between the two vectors is theta. Now the first term here written is A, so we move from A to B, we move from A towards B. Now if we move towards A towards B, we rotate our fingers like this, the screw will move upwards. If we rotate it like this, the screw will move down, and we rotate the screw this way anti-clockwise form, the screw will move up. Now as we have started from A and we moving towards B, so this will be an anti-clockwise movement, the screw will move upwards. So the vector n cap and the magnitude of this vector will be AB sine theta. So this is the resultant of the vector product of A and B. If it was B cross A, then we'd have moved from B towards A. That means in this fashion, B towards A. Now if this is A and this is B, then the direction of this vector will have to be downwards. Now talking about the geometrical interpretation of this vector product, let us take this example. Suppose OP represents vector A and OQ represents vector B. Now the component of B along this vector is the cos component B cos theta. Similarly, if we find out the sine component, so this will be the sine component, or rather B sine theta. Now take this point to be S, join this one, form another vector here, another point T, complete the parallelogram, name it as R. Now what is modulus of A cross B? That is AB sine theta. As we are given the mod value, we don't require to write the n unit vector. Now suppose A into B sine theta. What is A into B sine theta? Now for this rectangle, this one is A, this is B sine theta. So multiplication of these two things results in the area of the rectangle OPTS. That means you can write area of rectangle OPTS. Now from geometry we know that the area of this rectangle and the area of this parallelogram is the same, because they have the same base and the perpendicular distance is also the same. So area of OPRQ parallelogram, this is also the same parallelogram. Now this parallelogram comprises of two triangles. If we draw this one, join QP, if we join QP, so this comprises of two triangles. So 2 into area of triangle OPQ. So according to formula, A cross B is the area of a parallelogram formed by the two vectors. A cross B is the area of the parallelogram formed by the two vectors, equals twice the area of the triangle formed by OPQ. So we can write area of triangle OPQ is equal to half of the area of parallelogram OPRQ is equal to half of the modulus of vector A cross vector B. The properties of vector product. The first property is not commutative. Dot product was commutative, cross product is not commutative. So A cross vector B becomes equal to minus of B cross vector A. As we know from this diagram, if this was A cross B, the result is upwards, whereas B cross A will result in a downward vector. Now if this is vector A, now the downward vector will be minus of vector A, just the opposite vector. Similarly, A cross B is equal to minus of B cross A. The direction is just the opposite. Distributive, A cross distributive over addition. So A cross B plus C becomes A cross B plus A cross C. The next two properties are very easy. Vector product of two parallel vectors, that means the angle can be 0 or antiparallels. The angle is 180 degree. Sine 0 is also 0, sine 180 is also 0. So this will result in a value of 0. Now vector product of two identical vectors, vector A cross vector A, here also the angle will be 0, also resulting in a 0. The fifth property is the vector product of two perpendicular vectors. The angle between the two vectors is 90 degrees, sine 90 is 1, therefore it results in AB. The vector product between two unit vectors ij, jk or ki, this is a little bit tricky. I cross j means the magnitude of I, that is 1, magnitude of j, that is also 1, sine of 90, because x and y axis, the angle between them is 90 degree. And what will be this n cap? N cap will become k cap, because if this is the x axis, this is the y axis, we are moving from x to y. So we're moving, sorry, this is the x axis, this is the y axis, moving from x towards y. So if we move like this, this will be the direction of z. That means the unit vector along z axis will be k cap. So this one will, n cap will become here k cap. So 1 into 1 into sine 90 means sine 90 is also 1. So it results in k cap. So I cross vector j results in k cap. Similarly, if we multiply j cross k, it will result in I cap. And k cross I, it will result in j cap. All these three, if we have to remember in a very short form, we can represent this like this: I, j, k. So multiplying by I and j results in k. I and j multiplied, vector product becomes k. J cross k results in I. J cross k results in I. Again, k cross I results in a j. K cross I results in a j. Now, if we are given to find j cross I, now what will be the value of j cross I? If I cross j is equal to k, we can write j cross I is equal to minus k, because we are moving in the opposite direction. J cross I, it will result in k, but as we are moving opposite to the direction shown by this arrow, we can write it as minus k. Similarly, I cross k moving in the opposite direction results in j, but we have to write it as minus j. Now the last thing, how to find the vector product of two vectors. Suppose vector A is given as minus 5i plus 3j minus 5k, and B as 2i minus j plus 4k. We arrange this in a determinant form. This is not the determinant form. I, j, k, as vector A is first, we write the vector A coefficients of I, j, k first with the signs minus 5, 3 and minus 5. Don't forget to write it with the signs. Now second vector is B. Similarly, we write 2, minus 1 and 4. 2, minus 1 and 4. Now this is a 3 into 3 determinant, because there are 3 rows and 3 columns. First one is a row, second one is the column. We have to then convert it into 2 into 2 matrices, determinants. 2 into 2 determinants, that is row and column is 2 into 2. Now how to do that? We can expand it. If we write I here, we close this 2, the row and column. The remaining values is 3, minus 1, minus 5 and 4. 3, minus 1, minus 5 and 4. Similarly, minus j, we cover up this column and this row. The remaining will be minus 5, 2 and 4. And similarly, if we hide the row and column of k, it will be minus 5, 3, 2, minus 1. So we have converted the 3 into 3 vectors, 3 into 3 determinants into 2 into 2 determinants. Now you have noticed that the first one is of a positive sign, second one is a negative, and third one is again positive. Now the multiplication is done in this form. First these two are multiplied 12 and minus sign, then these two are multiplied. Minus 5 minus 1 gives 5. Again the second format, minus 5 into 4, that is minus 20. Minus of minus 5, and what does minus 5 and minus 5 and 2 gives? Minus 10. So minus minus becomes plus here. Now minus 5 into 1, minus 1 gives 5, and 3 into 2 is 6. So this one becomes 7i minus j into plus 10. So minus 10 here and minus 1 here. So 7i plus 10j minus k. A vector cross B vector. Now if you are asked to find the magnitude of this vector, similar to the things we have learnt earlier, 7 square plus 10 square plus minus 1 square. If we calculate this, we are going to get it as 12.25 from the calculator. And unit vector along this A cross B direction, A cross B vector direction, that is the magnitude, the vector divided by its magnitude, the n cap. It will be 7i plus 10j minus k by 12.25. So 7 by 12.25i plus 10 by 12.25j minus 1 by 12.25k.